Good morning. Welcome to the session. So in today's session, we are going to derive integrated rate equations for zero order reaction as well as first order reaction. We are going to derive what? Integrated rate equation for a zero order reaction as well as first order reaction. Now what do you mean by zero order reaction? What is the definition of zero order reaction? In the previous class, I told you about zero order reaction. Zero order reaction means a reaction in which reaction rate it is proportional to zeroth power. Reaction rate it is directly proportional to zeroth power of concentration of the reactant, or reaction rate it is independent of concentration of the reactant. Such a reaction it is called as what? It is called as zero order reaction. It is what? Zero order reaction. Example for zero order reaction: reactions taking place on the catalyst surface and also enzyme catalyzed reactions. Enzyme catalyzed reactions and reactions taking place on the catalyst surface, they are examples for zero order reaction. Let us derive it once again. In the last class, once we derived this derivation, so once again we are going to derive the expression for zero order reaction. I will take a general reaction. A reactant are producing products. Reactant are producing products. Rate law for this reaction can be written as, see, rate it is equal to what? K into concentration of the reactant. Since it is zero order, power it is 0. Power it is what? 0. So rate it is given by, rate it is expressed as what? Minus dr by dt. Minus dr by dt. That is change in concentration with respect to what? With respect to time. So change in the concentration of the reactant with respect to time, it is called as what? It is called as rate. It is equal to what? K into concentration of the reactant power 0. Any term to the power 0 means it is 1. So it is equal to what? It is equal to K. On rearranging, or cross multiply, will get minus dr it is equal to K into dt. Minus dr equal to what? K into dt, or plus dr it is equal to minus K dt. It is equal to what? Minus K dt. Next, integrating on both the sides. Integrating on both the sides. On integrating, that is integral of dr, it is equal to, see, K it is a constant cannot be integrated. We can take it outside. K it is taken outside. So K into integral of dt. Integral of what? Dt. So integration and differentiation, it is inverse to one another. So they will cancel out. We will get r, it is equal to minus K. Integral of dt it is t. So t plus I, plus what? Plus I. This equation I will name it as equation 1, where I it is called as what? Integral constant. What is I? It is integral constant. Next step, we shall find out the value of I. That is to find the value of integral constant I. To find the value of integral constant I will use initial condition. I will use what? Initial condition. That is when time t equal to 0. When time t equal to 0. That means in the beginning, concentration of the reactant, that is R, can be taken as what? It can be taken as R0. Concentration of the reactant can be taken as R0, or it is R0, or it is what? R0. Let us substitute these values in equation 1. So substituting these values in equation 1 we get, let us substitute the value. In the place of t I have tried 0, in the place of r I have tried r0. So it is r0 it is equal to minus, it is equal to what? Minus k into t value is 0 plus I. It is r0 equal to minus k into 0 plus I, or r0 k into 0, it is 0, it is I. So what is the value of I? I it is equal to r0. I equal to what? r0. Again substitute the value of I in equation 1. On substituting the value of I in equation 1, we get, that is r equal to what? Minus kt plus I. What is the value of I? I it is r0. Rearrange the terms. Take this minus kt to the left hand side. So it becomes plus kt. Already r0 it is present on the right hand side. r0, I will take this r to the right hand side. Okay, so minus r. So plus kt it is equal to r0 minus r, or k it is equal to r0 minus r by t. So k it is equal to what? r0 minus r by t. Now this expression, it is called as what? Integrated rate equation for what? For a zero order reaction. So integrated rate equation for a zero order reaction, that is k it is equal to r0, k it is equal to what? r0 minus r by what? By t. r0 minus r by t. Say this equation, will take it as 2. Now equation 2, it is of the form y is equal to mx plus c. Equation 2, it is of the form y is equal to mx plus c. I will write it here. What is that equation 2? See, r it is equal to minus kt plus it is r0. R equal to minus kt plus r0. This is of the form y is equal to mx plus c. Y is equal to mx plus c. What is y is equal to mx plus c? Y equal to mx plus c. It is the equation of the straight line with slope equal to m, intercept equal to c. Slope equal to m, intercept equal to c. Here value of slope m it is equal to minus k. So on plotting y against x, on plotting what? Y against x, we have to get a straight line. We have to get what? Get a straight line with slope equal to m, intercept equal to c. Here y it is r, correct? So concentration of the reactant, it is taken along y axis. What is m? M value is minus k, x value it is t. So time it is taken along x axis. Time it is taken along what? Taken along x axis. Concentration of the reactant, it is taken along y axis. Time it is taken along x axis. It is y versus x graph. That is concentration of the reactant versus time graph. So on plotting y versus x, we have to get what? We have to get a straight line with negative slope, correct? With negative slope like this. So we'll get a straight line with negative slope. Value of slope, it is equal to what? Minus k. Value of slope, it is equal to minus k. And this intercept value, what is this? This is value of intercept, it is what? It is r0. So on plotting concentration of the reactant versus time, we'll get a straight line with slope equal to minus k. Intercept, it is equal to what? It is equal to or not? Hope it is clear. Study this derivation properly. It is very, very important for the annual exam. Next one, zero order reaction, it is over. Next derivation, integrated rate equation for a first order reaction. For what? For a first order reaction. Example for first order reaction. Decomposition of dinitrogen pentoxide. Decomposition of what? Dinitrogen pentoxide. This is an example for first order reaction. Formula of dinitrogen pentoxide, it is N2O5. It decomposes to give nitrogen dioxide NO2 plus it is O2 plus it is what? O2. So N2O5, it is in gaseous state. NO2, it is a gas. O2, again it is what? It is a gas. So it is 2N2O5, 4NO2 plus what? Plus O2. Now this reaction, it is an example for what? Example for first order reaction. Rate law for this reaction, that is rate, it is equal to what? Equal to K into concentration of the reactant, that is N2O5. Concentration of the reactant N2O5. Since it is a first order reaction, power it is 1. Power it is what? 1. So order it is equal to 1. It is a first order reaction. Then what is the definition of first order reaction? First order reaction means it is a chemical reaction. It is what? It is a chemical reaction in which reaction rate, it is a chemical reaction in which reaction rate, it is directly proportional to concentration of the reactant. Concentration of the reactant, power it is 1. Power it is what? 1. So what is first order reaction? Chemical reaction in which reaction rate, it is directly proportional to first power of, directly proportional to what? First power of concentration of the reactant. Such a reaction, it is called as what? First order reaction. What is the meaning of this? See, on doubling the concentration of the reactant, rate also increases by 2 times only. Sorry, on doubling the concentration of the reactant, rate also increases by 2 times. On tripling the concentration of the reactant, if I increase the concentration of the reactant by 3 times, rate also increases by 3 times only. So if I double the concentration, rate also doubles. If I increase the concentration by 3 times, rate also increases by 3 times. So these variations, if it is seen, then such a reaction, it is named to be what? Named to be a first order reaction. So first order reaction means rate of the reaction, it is directly proportional to first power. Directly proportional to what? First power of the concentration of the reactant. One more example we can take. Hydrogenation. Hydrogenation of ethene. Hydrogenation of what? Ethene. Formula of ethene, it is C2H4, addition of hydrogen. Hydrogenation means addition of hydrogen. On adding hydrogen, we will get C2H6. This is ethane. This is ethene. Ethene upon addition, that is with dihydrogen, it forms what? Forms ethane. So rate law for this reaction, it is found to be, rate it is equal to equal to what? K into concentration of the reactant, that is C2H4 power it is 1. C2H4 power it is what? Power it is 1. So order it is equal to 1. Order of the reaction it is equal to what? It is equal to 1. So first order reaction means what? It is a chemical reaction in which reaction rate it is directly proportional to molar concentration of the reactant, or rate of the reaction it is directly proportional to first power of concentration of the reactant. Such a reaction it is called first order reaction. Example for first order reaction: decomposition of dinitrogen pentoxide 1 more, hydrogenation of ethene. Here in this reaction rate depends only on the concentration of ethene. Rate does not depend upon the concentration of hydrogen, because hydrogen it is present in excess. Present in what? Present in excess. So rate does not depend upon concentration of hydrogen. It depends only on concentration of what? Concentration of ethene. So it is what? It is a first order reaction. Now let us derive the integrated rate equation. I will derive the integrated rate equation. Consider a general reaction, that is reactant R producing a product P. Since it is a first order reaction, what I can write? See, rate it is equal to what? K into concentration of the reactant. Since it is first order, power it is 1. So rate it is equal to K into concentration of the reactant, power it is 1. Or rate can be written like this. So rate it is equal to minus dr by dt, minus dr by dt. It is equal to what? K into concentration of the reactant, power it is 1. Concentration of the reactant, power it is what? Power it is 1. On rearranging, I will rearrange the terms. What I can write? Minus dr. I will bring this r to the left hand side. It is K into r. When I bring this r to the left hand side, it becomes divided by r. Correct? So minus dr by r, it is equal to, cross multiply, it is K into dt. K into dt, or plus dr by r. dr by r, it is equal to minus K into dt. It is what? It is minus K into dt. So dr by r, it is equal to minus K into dt. I will continue. Integrating. Integrating on both the sides. So on integrating, that is dr by r, it is equal to minus K. It is a constant, it is taken outside. Integral of dt. Integral of what? Integral of dt. So integral of dr by r, it is equal to minus K into integral of dt. See, we know that differentiation, correct? So differentiation of log x, derivative of log x, it is equal to 1 by x. Derivative of log x, it is equal to what? It is equal to 1 by x. Differentiation and integration, they are inverse to one another, that we know, correct? So log x equal to 1 by x. Integral of 1 by x must be what? Must be log x only. Understood? So differentiation of log x, it is 1 by x. That means if I integrate 1 by x, what I would get? I would get log x. I would get what? Log x. Now here, dr by r, it is of the form dx by x only, correct? It is 1 by x dx. 1 by x dx. So dr by r, it is of the form dx by x. So dx by x is log x. Dr by r, integral of dr by r, it is what? It is log r, or I can write it is ln r. It is what? It is ln r, or it is log to the base e, I can write ln r log to the base e. It is natural logarithm. So ln r, it is equal to minus k integral of dt, it is t plus I. Let us name it as equation 1. So ln r, it is equal to minus kt plus what? Plus I, equation 1. Let us find the value of I. To find the value of I, let us use initial condition. When t equal to 0, that is in the beginning, concentration of the reactant R can be written as what? It is R0 or it is R0. When t equal to 0, R equal to R0. Substitute the values in equation 1. We get it is ln R0 equal to minus k, value of t it is 0, k into 0 plus what? Plus it is I. So ln R0, it is equal to k into 0 plus I, that is on substituting the values of t and r, or ln R0, it is equal k into 0, it is 0, ln R0, it is equal to I, ln R0, it is equal to I. So we got the value of I equal to ln R0. Substitute the value of I in equation 1. Substitute the value of I in equation 1. Let us substitute it. On the left hand side we have ln R, it is equal to minus kt plus I. What is the value of I? I equal to what? I equal to ln R0. I equal to what? Ln R0. I will bring this minus kt to the left hand side. It becomes plus kt. It is equal to ln R0, it is already present on the right hand side. So it is ln R0, take this ln R to the right hand side, it becomes minus ln R. So ln R0 minus ln R. So kt it is equal to ln R0 minus what? Minus ln R. Now this is of the form log m minus log n. It is of the form log m minus log n. Log m minus log n, it is equal to log m by n. It is equal to what? It is equal to log m by n. So what I can write? Kt it is equal to, I can write it is ln R0 by what? By R. Kt it is equal to ln R0 by R, or K it is equal to 1 by t. It is k into t. If I bring this t to the right hand side, it becomes by t, correct? So k it is equal to 1 by t. It is ln R0 by R. So k it is equal to what? 1 by t ln R0 by R. See, ln means what? See, ln means log to the base z. So to convert log to the base z to log to the base 10, we have to multiply it by 2.303, that is log to the base 10. Understood? Log to the base z, or I can write log to the base z, it is equal to 2.303 log to the base 10. 2.303 log to the base 10. So I have to multiply it by 2.303 in order to convert log to the base e to log to the base 10. So expression becomes on k equal to 2.303 by t, correct? 2.303 by t. So in the place of ln, what I wrote? 2.303 log. Ln it is equal to 2.303 log, that is R0 by R. So final expression K it is equal to 2.303 by T log R naught by R. Now this is the integrated rate equation for a first order reaction. So for a first order reaction we have K it is equal to what? 2.303 by T log R naught by R. Log R naught by R. Hope it is clear. Understood? Okay. Now this equation, I will take it as equation 2. So equation 2, again it is of the form, above equation. This one I will name it as equation 2. So equation 2, it is of the form y is equal to mx plus c, that is ln r minus kt plus it is ln r naught. This is equation 2. It is of the form y is equal to mx plus c. Y is equal to what? Mx plus c. On plotting y against x, that is on plotting ln r it is y, x it is what? X it is t, time it is along x axis, ln r it is taken along y axis, time it is taken along what? Time it is taken along x axis. On plotting ln r versus time, we have to get a straight line with slope equal to minus k, intercept equal to ln r naught, that is straight line with negative slope. So slope value it is minus k. This is y-intercept, value of y-intercept it is ln r naught, One more graph we can write. See the last expression. We have k equal to 2.303 by t log r naught by r. I can rearrange this expression. K into t by 2.303, it is equal to log r naught by r. Is it correct? K into t divided by 2.303, it is equal to log r naught by r. Or I can write log r naught by r, it is equal to k into t divided by 2.303, k into t divided by 2.303. Now this equation, it is of the form y is equal to mx, y is equal to mx. What is y is equal to mx? Y is equal to mx, it is the equation of a straight line without intercept. That means equation of a straight line passing through the origin with slope equal to m. Slope equal to m. Let us draw the graph. See, we have to take y and x. What is y here? It is log r naught by r. What is y? Log r naught by r. What is x? X value, it is t, correct? X it is t, because k it is a constant, 2.303 again it is a constant only. So x it is t, y it is log r naught by r. So on plotting y against x, we have to get a straight line without any intercept. That means it is passing through the origin. So slope it is equal to, what is the value of slope? So slope it is equal to k divided by 2.303, k divided by 2.303. So in today's class we derived two formulas. One is for one of them it is for zero order reaction, other expression it is for first order reaction. Integrated rate equations for zero order reaction and first order reaction. Both the derivations are very important for the annual exam point of view. Understood? So both the derivations you have to study. Either they will ask zero order reaction for the annual exam, or they will ask first order integrated rate equation for the exam. Both the derivations, I think it is clear. Okay. So thank you.